It became clear to me in the late 60s to early 70s, that was in the 20th century, that energy was a sort of master key for unlocking a lot of the world's tangle of problems around resources, environment, security, development, equity, a lot of other issues. And that energy efficiency was where most of the white space was. That's even more true today. 98, 99% of what you see in the media about energy is on supply. Nearly all the thinking and emphasis and investment is there. Well, not so much investment because that's more even, but it's very quiet in lots of little pieces like weatherizing buildings. About half of the world's decarbonization historically is from more productive use of the energy, and upwards of half the prospective decarbonization is the same, and yet it gets almost no respect and attention because there's no ribbon cutting.
Episode 100, and Dan and I could not be more proud and excited to be celebrating it with a true legend, Amory Lovins. For nearly 5 decades, Amory has been redefining how the world thinks about energy. He's the co-founder of the Rocky Mountain Institute, the mind behind the soft energy path, and the originator of the negawatt, proving the cheapest, cleanest power is the energy you never use. From helping design ultra-efficient factories and microgrids to advising presidents and CEOs, he's shown that efficiency, resilience, and profitability all ride together. This is the man who helped invent the future we're finally starting to build. So let's go. Amory, welcome to Renewable Rides. Dan and I couldn't be more proud and excited to have you on. This is definitely an honor. We've followed you for many, many years, and you're definitely an inspiration, and you've set the foundation for the incredible industry that we're all building together. So welcome.
Thank you. Good to be here.
We like to start with a question, what are you passionate about? So please share with our audience.
Within the very rapidly unfolding energy transition, I'm most excited about what I call integrative design. It's a proven method for designing buildings, factories, vehicles, processes, equipment, in a way that optimizes the whole system for multiple benefits rather than isolated parts for single benefits. And that makes the energy saving potential very much larger, but also cheaper. The building from which I'm speaking to you is a good example of that. It was an owner-builder project we did in 82 to 84. And behind me is a passive solar banana farm that
Awesome.
The tropical jungle with 100-odd kinds of higher plants that the house wraps around. But this is 2,200 meters up in the Rocky Mountains near Aspen, where it used to go to as low as minus 44 degrees Celsius. We've had 39 days of continuous midwinter cloud, but there's no heating system in the building. We don't burn anything. And it was cheaper to build that way in 1983 because you save more construction costs leaving out the heating system than you pay extra for the efficiency that got rid of the heating system. Out in the driveway, I've got a BMW i3 electric car that's about 300 kilos lighter than usual. That's important because about 2/3 of the energy it takes to move a car is caused by its weight. But the expensive carbon fiber that it's made of was paid for by needing fewer batteries and also by making the manufacturing very much simpler. Another example from industry and buildings, half the world's electricity runs motors, half the motor torque runs pumps and fans to move things like air and water through pipes and ducts. But it turns out if you make the pipes and ducts fat, short, and straight rather than skinny, long, and crooked, the usual method, you cut the friction by 80 to 90+%, 97% in this building. And that, of course, means you save correspondingly on the fan and pump energy. You also make the motor system about 5 or 10 times smaller. That's a good excuse to do 35 things to it that make it about twice as efficient. So if you include both the pipe and duct improvements and the motor system improvements, you could save a third of the world's electricity if everybody does this, or if you count just the pipes and ducts, about a fifth of the world's electricity. And yet this is not in any standard engineering text or government study or industry forecast or climate model. Why not? Because it's not a technology, it's a design method. And not many people yet think of design as a way to achieve speed and scale. So Joel Swisher and I teach integrative design at Stanford to help spread the good word. And if you go to efficiencyhub.stanford.edu, you can actually see my Stanford lectures.
That's amazing. We'll get them in the show notes. Where does that passion come from, Amory? Where did this realization of design opportunity arise?
Well, it became clear to me in the late 60s to early 70s that energy was a sort of master key for unlocking a lot of the world's tangle of problems around resources, environment, security, development, equity, a lot of other issues. And that energy efficiency was where most of the white space was. That's even more true today. 98, 99% of what you see in the media about energy is on supply. Nearly all the thinking and emphasis and investment is there. Well, not so much investment because that's more even, but it's very quiet in lots of little pieces like weatherizing buildings. You know, about half of the world's decarbonization historically is from more productive use of the energy, and upwards of half the prospective decarbonization is the same, and yet it gets almost no respect and attention because there's no ribbon cutting. There are few unusual rents for rent seekers to exploit. There isn't much room for corruption. It doesn't have some of the drivers that supply has. Now, of course, renewable supply is making extraordinary progress, and I'm all for it. It just has this natural partner that makes it a lot easier, faster, and cheaper. That's efficient use.
Amory, this is not the first time you've been sharing this type of approach. I mean, going all the way back, we're hitting nearly the 50-year anniversary mark of your energy strategy, the road not taken paper that was in Foreign Affairs, and in that you described the hard path and the soft path. And again, that was published in October, the beginning of October in 1976. So we've just surpassed the 49-year anniversary, coming up on the 50.
Yeah, watch for various events then.
Yeah. Well, so talk us through, like, in that paper you described the hard path, which is one of just focusing on supply, and not doing any of this kind of integrated design that you talked about, or the softer path, which ultimately is much more profitable, much more sustainable, much more resilient. Talk our listeners through kind of those two paths, and then what's happened over the last 49 years.
Well, in 1976, when the paper came out in the most establishment of establishment journals, so it had never before published a paper about energy, and it was the longest thing they'd ever published on anything. In those days, people thought the energy problem was where to get more energy, more of any kind from any source at any price, and of increasing quality, increasing electrification, whether the task justified very high quality or not. And if you think that's the problem, then the answer you might come up with, which almost everyone did, was coal, nuclear. In those days, gas was thought to be eminently scarce. We didn't yet have fracking. To give some extension of gas, and we thought it was all associated with oil, which turned out not to be. But it was mostly a coal and nuclear future. Renewables were scorned, viewed as a hippie fantasy. When people said solar, they meant solar hot water panels. Photovoltaics were only for satellites. The notion that wind power could ever be cost effective was dismissed as ridiculous. It was quite a different world. But that hard energy path of basically lots of coal and nuclear power plants and frontier hydrocarbons turned out not to be very attractive. It was too expensive, too slow, too unpleasant in a lot of ways. So in those days, there was no place you could go to study energy policy or strategy. It was what emerged de facto from what the energy engineers, lawyers, and accountants did in companies. And because there was no place I could study it, when I got curious about it, I had to kind of figure it out myself, and therefore didn't know too much. So I had the blessing of beginner's mind and started at the other end of the problem, turning it upside down and inside out, always a good way to start, by asking, what do we want energy for? We don't really want lumps of coal and raw kilowatt hours and barrels of sticky black goo. We want services like hot showers, cold beer. Actually, at the time I was living in England, so maybe cold showers and warm beer.
Yeah, exactly. A nice warm cask ale.
And other services might be comfort, mobility, baked bread, smelted alumina, and so on. So I started by asking, what are these end uses we're trying to do? And for each of them, how much energy, of what kind and quality, at what scale, from what source will do each job in the cheapest way? This was a very new kind of question, and it turned out to be very fruitful because it helped you think about how various ways of heating your house might compete with insulation and draft proofing. The resulting soft energy path combined efficient use with renewable sources that were accessible, the right size for the job, the right quality for the job. These are things I called soft technologies. And I made the case that wind power was indeed likely to become cost effective. Even I was not bold enough to suppose that photovoltaics might be too. But it looked like an efficiency and renewables future with transitional efficient use of some fossil fuels while you're getting the renewables and efficiency running. Would make sense, would make money. And this idea was supported by data and methodologies borrowed from the incumbent fossil and nuclear industries. They were very unhappy with that. It was later explained to me by the Dean of Divinity at Yale, who was really good at changing paradigms, that they were annoyed because I was invading the perimeter of their belief space and running around inside without permission and showing that what they were trying to do wouldn't work, but another approach would work better and they could provide better service at lower costs if they adopted it. So there followed a year of furious debate. The article was vehemently attacked, and there's actually a 10 centimeter thick fine print congressional hearing record that we call the paperweight of 36 tedious responses to fatuous critiques. It's quite amazing what they said in those days, like, If you try to decouple energy growth from economic growth, we'll be back to caves and candles. They really said that sort of thing. But after about a year, Dr. David Sternlight, who was chief economist of ARCO, Atlantic Richfield Oil Company, kind of put a stop to the ping pong by saying, well, I, for one, don't care if Lovins is only half right. That would be better performance than I've seen from the rest of them. Whereupon, some of the more thoughtful incumbents started to think about it a bit more instead of just lashing out reflexively, and realized that actually there were some good ideas in there they could make money on. Then they started to hire us to help them do it, and we've been very busy ever since.
Amory, I love it. And the oil and gas inception story of getting in the heads is great. Fast forward to today, and I think from a political perspective, they're still probably saying some of the same things that they were saying back then. If you were to design the grid today, what would you be encouraging people to be thinking about? Because it seems like we're having the same story of talking a lot about generation, when what we're saying is generation costs are coming down, but the cost to deliver it is going up because we're relying on aging grid infrastructure. We're reverting politically to pushing coal, gas, nuclear, whereas we've seen a lot of success in renewables. As you know, we're on the behind the meter on-site energy microgrid side of things. Reduce your consumption as much as possible and then generate and store your own energy at your facility. What would the grid of the US look like going forward if you were to design it on a napkin today?
I think there'd be more grid, but not nearly as much more as the official forecasts show, and often of different kinds, possibly in different places, and doing different things. The classical grid, transmission and then distribution, was a way of spreading out huge amounts of centrally generated power from big thermal stations and old hydro dams to distributed users who would then send you a check in return for the electrons. But meanwhile, we're getting more efficient in using the electricity, and there's another factor 5 to go on that very profitably. If you use integrative design, factor 2 or 3 if you don't. The distributed generation, both renewable and non-renewable, including industrial cogeneration, is growing very rapidly, and in some places at a just astounding rate, particularly in China. They're the world leader in renewables and have a coherent and consistently pursued policy to do that. So they're becoming the first electrostate as the U.S. tries to revert to being a petrostate. That's not going to work very well. So a lot of the electricity that used to come from afar can come from as near as your roof, which also makes the system much more resilient because there's less to go wrong between the supply and the use. 98, 99% of grid failures classically, of power failures classically occur in the grid. So if you're not needing it to get power off your roof, that's a 2-order of magnitude improvement in reliability. Also, we have something else that I'm not independent about, but I can still tell you about it. The reason I'm not independent is I actually advise the company that makes it. But this is a new kind of transmission conductor, and normally it would have a braided steel core and braided aluminum strands around it. But in this case, the core is carbon fiber composite, which is about 7 times as strong per kilogram, and protected by an aluminum tube, mechanically and chemically.
Wow.
So it actually is quite flexible. It comes on big spools. And you can use it to reconductor an existing transmission line on the same towers, but because the core is much lighter and it doesn't sag when it gets hot, so it's safer. You can actually wrap more strands around it, and perhaps you can see that they have a trapezoidal cross-section, so they pack tightly, so there's less icing and less wind loading.
It's amazing.
So altogether, this handles 2 or 3 times the current of a standard conductor of the same weight.
Wow.
And then for their next trick, they're going to put an optical fiber down the core and put laser light in it and do Raman spectroscopy, so that within 1 or 2 meters spatial resolution, you get a continuous real-time readout of the temperature, stress, and sag. Therefore, you can dynamically load each conductor to the maximum current it can safely carry in the conditions it's actually experiencing it. So there's a Haas School study from Berkeley saying if you had just doubled current carrying capacity, not as good as these are, you could avoid probably about 4/5 of the new transmission corridors, new rights of way normally required. That's the really hard part, especially if it's interstate, and it can take you 10 years and you may not even get it in the end, and it's also quite expensive. But those could be displaced by simple reconductoring using standard equipment, tools, and training. So that means you could, Haas found, get to about a 90% renewable powering of the grid in the U.S. In about 10 years. And that's a very different world than the transmission constrained world that most people still think about and try to realize. The grid is also changing in, if you like, topology and purpose. Instead of being a way to spread out centralized chunks of power to distributed users, it's turning into a kind of web that gracefully handles power flows every which way. And it's no longer problematic if you designed for it to have a chunk of solar or wind power feed more power back. It's called backflow than was being delivered from elsewhere. Well, that gives you a lot more flexibility, resilience, ability to use sources that complement each other at different times, ability to match loads better. The whole thing gets much more functional, reliable, resilient, affordable.
Amory, I actually, when I was not too long ago listening to one of your conversations, you shared something, and I don't remember, I think you referenced someone, and I'm sure you can hear, that said this, but it was basically saying that we're moving from a world in which we project demand or forecast demand and schedule supply to a world in which we are forecasting supply and scheduling demand, which is largely what you were talking about there as we build this web and different energy flows. Can you expand upon that?
That's a very good way to think about it, because we're now quite good at predicting the variable output of solar and wind power. For example, the East Danish wind operators bid their wind power into the continental auction a day ahead with the same confidence they would have if they ran a fossil fuel plant. They're that confident that they'll be able to deliver the contracted 4 megawatts next day on schedule. The same is true of solar. Of course, there are clouds pass and so on, but if you're sending from a significant area, that all averages out. And just to give you an idea of other things you can do, we worked out many, many years ago that if you analyze a wind belt from the Canadian border to West Texas, running down the middle of the United States, and you choose, you pair sites that are anti-correlated, so if the wind is blowing here, it's probably not blowing there, and vice versa, you can get about the same firm power output from half as much capacity. So the developers were leaving half their money on the table by not doing that. And some of them, reading our paper, came along and did it afterwards with synthetic contracts, matching up those anti-correlated sites. And of course, in most places, wind and solar complement each other. You also have some dispatchable renewables. There's small hydro, geothermal, solar thermal electric, burning obsolete energy studies. That's my favorite, a very abundant resource. And we actually did a simulation that's online in which we looked at Texas, the so-called ERCOT power pool in 2050 on a typical summer week, and found that you could run all of Texas with its difficult climates, no big hydro, almost isolated from the rest of the country. You could run it entirely on renewables, very profitably at current prices with no bulk storage. That surprised a lot of people. You would need only smart bidirectional charging of electric vehicles. That's not utility-specific storage, but more and more cars and trucks now are coming out with the ability to exchange power and other services with the grid. And that's going to be an immense resource. And also, we used thermal storage, specifically ice storage air conditioning, which is on the market for both big and small buildings. And those two turned out to be enough to even everything out. So it would run just fine. And that's a difficult case. Of course, there are altogether not just those two, but another 7 ways to make sure the grid stays reliable as it becomes renewable. And the cheapest ones, the very most profitable ones, are actually on the demand side, negawatts and flexawatts, that is efficient and timely use. And those resources are both about 3 times bigger than we used to think, or than most studies still assume. And then there's diversification by type and location. There's better forecasting. It's a portfolio altogether of about 10 approaches, not needing fossil backup, not needing big grid batteries. Now, big grid batteries work great. They're profitable. They are very impressive, for example, in South Australia, a mostly isolated grid that is running, last I looked, 72% over a year on just solar and wind. In other words, variable renewables, not others. And heading for 100% by the end of 2027. And that is stabilized by big batteries. There's 50-odd sets of those around Australia, and those in South Australia are especially impressive. In fact, the first one, which was from Tesla, before they even formally went on the market, was hooked up a few days before it was going to be officially opened. And right away, one of the remote lignite units failed, and the battery jumped right in and fixed it very quickly before the backup designated lignite unit even knew there was a problem. Yeah, so they work fine, but it turns out I haven't found a place yet where you actually need them, because you have 9 other ways to do the same thing, carbon-free and with good economics. So, there's a much bigger array of grid stabilizing resources than most people are looking at.
Well, going back to the way we opened the conversation and you talking about integrated design, what I'm hearing from you is not just integrated design at a house like yours or an individual facility, but what you're talking about is an integrated design amongst all the different players in the grid, supply, demand, peer-to-peer. What's standing in our way from unlocking this better energy future?
Well, the barriers are all between our ears, individually or collectively in institutions that were designed for a very different world that's rapidly going away. And you know, institutional barriers are real and challenging, and they need diplomatic skill and relentless patience and a lot of factual understanding that is not yet widespread. In fact, there's a lot of disinformation. So, for example, there's the common assumption that you need fossil or nuclear plants to keep the lights on because renewables can't do that.
Yeah.
Because the sun doesn't, there's things like night and cloud and calm. Yeah, we knew about those. But as I've described, they have available solutions that work very well. There are a lot of countries that are in the 50 to 100% or more renewably powered right now. Some of them have little or no hydropower, but they hook up the other bits properly to make the grid actually very reliable. Denmark's a good example. They're well in the 80s of percent renewably powered. They have no hydropower. Country's practically flat. They're over half wind powered, and then a lot of ag waste cogeneration, highly distributed in most cases, and a bit of solar power, even though it's often quite a cloudy, rainy place. And it works just fine. Of course, they are hooked to the continental grid, which in a way they use like a giant battery, even including some Norwegian hydro. But isn't it interesting that Denmark and Germany have power supply over 5 times as reliable as Americans do?
Yeah.
Yeah, there are a lot of interesting cases like this. In fact, back to South Australia, there are 37 companies as of a month or two ago wanting to set up factories there to take advantage of the affordable, ultra-reliable, all-green power, almost all, but all within a couple of years before they could build the factory. And if they all did that, it would increase the total electricity use by about tenfold. But isn't that interesting? Industries, including heavy industries, flocking to an all-solar and wind-powered place soon, 72% last year, because it's a better deal for them. This is the opposite of how we'll have to deindustrialize if we renew renewables, that myth.
Yeah.
And, it fits. Rio Tinto has chosen solar and wind as the backbone of its power supply for its next aluminum smelting complex. In my own state of Colorado, there's 1,000 people working at an almost all solar-powered steel mill. Yes, renewables can do big, difficult things. They're not confined to running your hut in the mountains. And I think a lot of people just don't understand yet what renewables can do or how fast they can be.
Yeah.
In the month of May 2025, just before the tariff changed, China installed a gigawatt of solar or wind power every 6.25 hours around the clock.
Wow.
That's equivalent in output to a giant coal or nuclear or gas plant every day.
That's insane.
Yeah, and they're accelerating further.
And Amory, what would you say to the people? Like, we very often run into this in terms of, almost the misconception around we generate our own oil and gas, and so that's a more secure power supply versus reliable.
Hang on, we don't generate oil and gas. We
produce.
We mine them. They're gone.
There we
Burn
go.
them once. Yeah.
Versus relying on China for technology. Like, what would you say to that to really sort of make people aware of the opportunity of relying on technology versus combustible fuels?
Well, if you buy a solar panel from China, it's yours and it'll last for many decades. If you buy oil from domestic or foreign extractors of oil or gas, you burn it once and it's gone. Actually, I wish it were gone. It actually turns into global weirding because it goes in the air where it shouldn't be. We have the right amount of carbon, but it's going in the wrong places. It's going out of soil and biomass and into air and oceans where it doesn't belong. Anyway, now, of course, we do make some of our own solar and wind equipment. We ought to make a lot more of it. Strangely, the current administration is trying to block those projects and encourage people instead to use more fossil fuel. That's rather strange because they also have an ambition of very rapid build out of AI data centers that they want to run on natural gas because they don't believe renewables work. And that the gas is the slowest and costliest option and can't come in quickly enough to run the data centers. The only thing quick enough is renewables, which are also cheaper and have no fuel, so they're not exposed to volatile fuel prices. There's a big order book right now for aeroderivative that is based on airplane engine simple cycle gas turbines in the US to try to get data centers to market quicker, because if you wait for a more efficient combined cycle gas plant, that steam turbine production's booked up till about 2031, way too late. But let me give you an idea of how quickly renewables can work. On June 27th, I visited Sparks, Nevada, about less than an hour drive east of Reno, out in the desert, where an activity of the dominant battery recycling company, J.B. Straubel's Redwood Materials, is now running under the name Redwood Energy. And they had built a very interesting thing, the biggest solar microgrid in North America. They laid a whole bunch of photovoltaics, 20 megawatts of them, on the ground. No racks, no concrete. They hooked them up to about 800 used or salvaged EV battery packs wrapped in white tarp set on cinder blocks on the desert floor, with plenty of room to drive your forklift around, so that if one of these second life batteries dies after 3 years, you just hot swap in another one. And also, they're far enough apart that if one catches on fire, it won't affect the others. Because the company has mastered power electronics and software, they were able to connect these 800 very disparate batteries, different voltages, chemistries, curves, sizes, into a single, roughly 63 megawatt hour unified storage device. So the result is a 24/7, 365, 100% solar microgrid, not connected to the utility grid, but producing cheaper power, less than the grid's 8 cents a kilowatt hour. They're not saying how much less, but it's obviously attractive. Far more reliable than grid power, and they built the whole thing in 4 months. Now, it only takes, it takes about 18 to 30 months to build a data center. And now you don't need to argue about whether Ms. Jones' new data center is going to get built. A lot of them won't. because you can wait till it's mostly built and then yourself or by competitive bid put up one of these 4-month pop-up power supplies. That particular one happens to be running data centers from the get-go. They're modular, containerized data centers from Crusoe, which also makes a lot of the hyperscale giant ones. And when I visited, they had 2 of them. I think they're planning 4 or 5. They may have some of those in by now too. But they have 12 megawatts of AC round-the-clock solar power to work with. And it can be bigger than that. They're designing some an order of magnitude bigger. It can be scrunched together. If land's more expensive than the Nevada desert, you can stack them up in a way that's still fire safe. In fact, David Roberts' Volts program a few days ago did a wonderful interview with their CTO, Colin Campbell, with some very interesting insights, including that they make several times as much money from this second life battery operation in microgrids as they do from recycling the battery after that's done.
And Amory, you touched on this. Do you think a distributed data center future is more likely than these sort of mega gigawatt size hyperscaled operations?
Well, I think some of those will get built and a smaller fraction of them may make money. Most data centers are not actually AI. They're conventional searches, transactions, database use, and so on. But I think the AI enterprise, about $3 trillion going in now, mostly from big tech companies, I think that's looking more and more like a bubble. And in fact, I did a paper on this in May called Artificial Intelligence Meets Natural Stupidity, Managing the Risks, which you'll find at ai-electricity.stanford.edu. And let me summarize some of what I found there. If you build a power supply to run somebody's giant data center, you're betting against at least half a dozen things that don't look like very good bets to assume won't happen. First of all, there's some big questions about the ultimate market and revenue stream from artificial intelligence. The hallucinations are a feature, not well, they're a feature and a bug, but I don't think we'll get rid of them. The large language models look very unlikely now to magically produce super intelligence by just brute force making them bigger. And there are a dozen or so categories of technical AI application that are useful and profitable in things like pattern recognition, but they only produce maybe a tenth the revenue you would need to pay off the investments being made. Nearly all the companies that try to use AI as a general business tool report no or negative net benefit. I don't use the stuff myself because it would take me more time to check and fix it than to work without it. So I think there are basic questions about how many data centers will thrive, but also about how many will be built, because a lot of developers shop their projects around to different utilities looking for the better deal, and then many of those utilities put that project into their plans, even though there's only one project being multiply counted. Then there are the speculators who have maybe a piece of land with water and near a power line and say, hey, maybe I could build a data center here and get rich. Let me try to put together the rest of the deal. So they hustle to try to assemble a project that isn't real and is very unlikely to happen. Then there is the little problem of competitive power supplies like the solar microgrid I described. And there's another whole alternative for the projects that are built and do thrive, even though there isn't enough revenue to support them all. So a lot of them probably will go bust. But another alternative power supply is to run them flexibly, because although some things an AI data center does have to run all the time and quickly, others don't. You can do training when you want. And there was a great, I think, April study from Nicholas School at Duke University and several others later showing if you run flexibly the activities that can run flexibly, then you can perfectly well cut back your use by half or so for some tens of hours a year known in advance without disrupting the customer experience. Well, it turns out if you do that, you just freed up 50 to 100 plus gigawatts of U.S. power supply using existing utility assets without having to build new stuff. So you're betting that that also is not going to work, even though Google is already doing it and bidding flexible data center operation into utility auctions or power pool auctions. So that's real. And there's other layers of uncertainty as well, but I think when you put all this together, the kind of giant build out of AI data centers and big fossil fueled or even nuclear power supplies is very unlikely to work, and a lot of people are going to lose a lot of money, which is worrying because almost all the economic growth so far in 2025 has been in AI. There isn't much else going on.
Yeah, that's right.
And if those companies start to lose their market cap, that could crash a good part of the economy. In fact, there's an interesting comment someone made the other day that if China wanted to triumph in a non-military way over the United States, it would just have to drive down, which it's equipped to do, the share price of the big tech companies, and that would crash our economy, or it could at least. It's a worrying time. We have enough stresses on the economy already without having it so heavily concentrated in one sector that looks like a trembly bubble.
Yeah. Well, and there's a compared to the larger populace, there's a small handful of folks that are in that AI data center space. Most business leaders, manufacturing, logistics, retail, whatever, are not, but they're being impacted. What do you think the froth in this market is going to do to commercial, industrial, energy consumers, and how are these knock-on effects going to be felt for the coming 5, 10 plus years?
Well, there are many claims and some backed up by evidence that astute use of AI tools can make many buildings run more efficiently, can improve industrial process management, and so on, and that these things can save significant amounts of energy. Well, in Holly Alpine also have a nonprofit they spun out of Microsoft, where they were AI executives, and they have noticed that at the same time, AI tools are very widely sold and used to find and extract more hydrocarbons, producing what they call enabled emissions that would otherwise not happen or cost a lot more. They will shortly publish some important evidence about how that affects the net benefit, if any, of AI for energy and carbon. But that had not been counted before. People had counted potential energy savings, but not extra emissions from using the tools. Now, again, there are good applications for AI. They're just way, way smaller than you need to pay for what's being built. And I think where AI is likely to evolve is away from large language models and instead toward specialized tools that are fit for a specific purpose. They tend to be lean, specialized models using machine learning to do things like process control. And those can be very effective, but they take a great deal less computing. And again, they won't fill up or support the revenue needs of what's being built now, which is kind of herd behavior, but I fear heading toward the cliff. Another thing you're betting against if you build power supplies for a big data center is the increasing efficiency of converting electricity into AI services. In very round numbers, that's quadrupling every year, which means if you're counting on electricity purchases to pay for your power plant over several decades, you better count on the data centers being able to quadruple its sale of AI services every year to keep using the same amount of electricity. And that's a pretty risky bet.
Yeah, that is a very big bet.
Amory, you talk about retiring old mindsets, and for the business leaders kind of listening in today, some of the writing is on the wall in terms of the current state of the grid and the current policy driving up energy rates, reducing reliability, power quality. What mindsets do they need to shift to really position themselves to shift from passive consumers to more active consumers of energy, owning it, having more control over it, to position their businesses for long-term success versus reacting to the market?
Well, use your energy very efficiently and timely. Get up to speed on integrative design and apply it everywhere. And build or have others build for you more local, renewable supply designed to work with or without the grid. That's a point we often forget. A lot of renewables are hooked up in such a way that if the grid fails, they can't work. That's stupid. We ought to be building resilience from the bottom up, one residential or commercial roof at a time, et cetera, by making them able to auto-island. And there's a national standard which has some foreign analogies. It's IEEE 1547 that protects line workers from not following their safety precautions, which say to assume a line's energized even if they think it's not, like assuming a gun is loaded. But you can protect the line workers and still be able to cut loose from the grid and run on your own if the grid fails. And then when the grid comes back, your smart inverter will detect that, wait a while to make sure it's real, not just a recloser transient, and then resync and reconnect all without interrupting the load. So that's why my house here has had 2 power failures in a quarter century running on solar, and both times it was because a battery cell failed. I've got to get a better battery that doesn't do that. I'm still on lead acid instead of lithium. So there's some other things I think business leaders should pay attention to that are outside their own purview. For example, my valley has 11 gasoline and diesel filling stations, all of which would be unable to pump if the grid failed. So your folks can't get to work unless they're on EVs. They should do that too. Help them charge at work. You can sell back their battery capacity to the utility and during the day when your solar cells are cranking and so on. But it means our local co-op is getting interested in putting solar and batteries on all the filling stations because it's really dumb to make mobility fuels depend on electric grids. Why do we do that? So there's a lot of insecurities built into our existing system that all business leaders should be concerned about. But in whatever kind of business you're in, you have a lot of tools at your disposal to make energy a source of profit rather than cost and security rather than anxiety.
Yeah, I think too the we're in this interesting time where for nearly 20 years we had a relatively flat load growth, and now we've hit this inflection point. And so the models of the last couple decades may not be what we can predict looking forward. I'm curious. You talk about the pace of change being set by the insurgents, and I think most people would recognize insurgents as like a more common term of disruptors, and we certainly identify as insurgents or disruptors. And so, what are some of the smartest ways that you have to enlist the incumbents or route around them without getting stuck in the trenches?
Well, the incumbents have very important skills and capabilities, many of which will be useful in the transition, as long as they don't get stuck looking backwards. They should be, all of us should be enabling the next energy system, not trying to protect the old one. Those are sunk costs. They are increasingly risky and unattractive.
Yeah.
And the market leaders will be smart enough to get out of them quickly, sell them to their competitors perhaps, or just write them off, because the replacement technologies are often cheaper than just running existing legacy assets, let alone building more of them, for which there's no business case in any place I can think of. Some of the incumbents get this, but these are often traditional industries with very conservative cultures, and that's why the lights stay on. It's a good thing. So the juggle that utility leaders have to do, the hottest seat in American industry, is to keep the vital technical rigor of their culture and care and execution, but do different things. And I'm blessed to be a member out here in rural western Colorado of a cooperative. It happens to be called Holy Cross Energy, named for a geological feature. It looks like a cross on one of our mountainsides, run by a PhD electrical engineer who was a senior NREL executive, named Brian Hannigan, one of the best utility execs anywhere. And he's, last I looked, 85% renewable, heading for 100, has superlative reliability, and far from that making his rates soar, as the political rhetoric would have us believe. They're stable, and he's charging about a third less than the state average.
Yeah, wow. That's amazing.
Yeah, so he's doing it right, and bigger utilities can too.
And Amory, before we jump into final few questions, I think you refer to yourself as a practitioner of applied hope throughout your career. Where have you seen that hope turn into action and adoption that you've kind of been most proud of or most excited about?
Oh boy. Well, we found in industry typically 30 to 60% energy savings on retrofit, 40 to 90 odd percent in new build, with great economics. And in fact, the new build is almost always lower capital cost.
Yep.
So one of my most exciting projects was with Paul Westbrook at Texas Instruments. He has a book out called The Joy of Efficiency. I commend to your attention. And they were building a wafer fab, semiconductor fabrication plant, which ended up being built in Texas, not China, saving 1,000 high-tech American jobs, because we were able to cut $230 million out of the capital cost, or about 30%.
Wow.
While saving, as I recall, 40% of the energy.
That's amazing.
And in later designs, we could do even better than that. And that set off a revolution in Texas Instruments that's had them do new and retrofit plants all over the world to reduce their water and energy intensity and carbon intensity by 60 odd to 70 odd percent per equivalent wafer made, and they are continuing to progress there. Funny thing about efficiency, you don't run out of it. It keeps getting bigger. It's like low-hanging fruit is not the right metaphor because the fruit's fallen down. It's mushing up around your ankles, and it grows back faster than you can harvest it.
That's great.
That's an excellent analogy.
And we've had other successes in a lot of buildings, thousands of buildings, and a bit in vehicles, but the auto industry has been harder because most of the firms that were culturally most ready to make a big shift to ultralight materials either couldn't muster the guts and organization to do it, or tried it and did well, and then some new CEO would come in who forgot why they did it. So I can't point to decisive successes yet in road vehicle or in cars and light trucks. I think the Tesla Semi will lead a new vanguard in heavy trucks, and it's coming on the market within months. And I'm also very excited about where we're headed with advanced aviation, so that reference to ai-electricity.stanford.edu will give you as a free bonus my latest lecture on flight without fuel. Of course, the logo of that annual Stanford lecture I do on super efficient and electric aviation is a circle slashed through a pterodactyl. But the pterodactyl had the last laugh. I later learned that the pterosaurs, those flying reptiles, had 10 or 11 meter wingspans. That's 3 times as big as anything that flies on Earth today. They did that with things like paper-thin bones, but with sort of splines inside to keep it stiff and strong, and very sophisticated graduated porosity at the ends. Really amazing engineering. So there's a whole new field called paleobiomimicry, mining these design lessons from 1/6 of a billion years ago to inform today's aerospace engineering.
That's incredible. A better use of old dinosaurs than oil, maybe.
yeah, then digging up and burning the fossilized remains of primeval swamp goo and dinosaur poop.
Yes, exactly. Amory, this has been incredible. One of the things that's resonated most is pretty much everything that you've talked about is the economic benefits of these things. Obviously, there's other additional benefits around sustainability, but that's not what's going to get business leaders to move. It's all about the economics. So I appreciate your pragmatism there and going down that path. Amory, I think this is a good transition. We always close with our guests in a power surge round, and so I'll kick things off here. If you could be any one energy technology, what would it be and why?
I would be advanced efficiency through integrative design, because I'm cheaper, faster, and more impactful than anything on the supply side, exciting though those options are.
Love it. And Amory, you've referred to several resources for listeners to check out, and we'll put them in the show notes. Are there any other standout sources of information, books, podcasts, newsletters that you regularly draw on or would recommend to our listeners?
I follow Bloomberg New Energy Finance and Lazard. I follow David Roberts' Volts.WTF interview series. There are a lot of specialized sources, but I think those are among the better general ones for keeping up with things. And Utility Dive is also very useful. I would also suggest that you follow rmi.org. That's Rocky Mountain Institute, which I co-founded in '82. and Ember, the British Energy Analytics Center. And if you want to know about energy assets worldwide, there's an incredible open database at GEM, that's the Global Energy Monitor, and everything that is built or being built is on there, along with who owns it, who really owns it, not the shell companies.
Excellent. Amory, having followed your work for nearly 2 decades now, you've already been a big impact on my career. I'm curious, you've done so much in your span of work. If you were to finish this statement, how would you finish it? In my life, I will have been successful when?
I will have been successful when advanced efficiency through integrative design for saving energy and materials is the standard practice rather than a rarity, and when all new energy supply is renewable, fair, affordable, benign, and resilient.
Nice. Love it. Aligns very well, and we resonates a lot. And I think just to close out, Amory, for our listeners who want to become practitioners of applied hope, what's the smallest credible step they could take in the next 30 days that would compound over the next 30 years?
Find out the best people to help you understand your energy efficiency opportunities, and then start applying their practice to your opportunities.
Love it. And we're a big fan of Ember. We had Kings Mill on the podcast not long ago, and we love the whole Electritech revolution piece that he published. Dan, what a legend.
That was unreal. I thoroughly enjoyed that, and look forward to continuing to learn from him for many more years to come.
Yeah. I just love how considered, thoughtful, researched, and how it's all backed in data science and just smart engineering. It's just, it makes so much sense, doesn't it? And I love that he closed with what success looks like for him, because he's been very consistent on this journey, and I think he knows there's probably never an end point. But how do you get more and more of this adoption at scale?
Yeah. Well, and I think the thing that resonated with me the most, and I shared it with him there towards the end, of everything he talked about is around the economics of this.
Yeah.
And both the near term, but also the bigger picture, longer term economics of these decisions that get made. And I think, thinking back to some of our previous guests talking about kind of working within the system, he understands that that's what's going to get movement and going to get change. I think, unfortunately, too often business leaders, whether by their own volition or just by the nature of the businesses that they work within, have to think in quarters or maybe years. But when you zoom out and look at the longer term picture, this is the path that's going to yield the best economic and societal outcomes. And so I really appreciate his really pragmatic approach to that. How about yourself, Gareth?
Yeah, I think broadly across the board, it was that purposeful adaptation. I think there's a lot in holding onto the past. There's a lot of knee-jerk reaction. There's a lot of let's try and jump on an opportunity short term, instead of actually really thinking it through and adapting with a vision of where it can lead to and the opportunities and the risks at stake. And that ranges from the policy level of reverting to being very oil and gas centric. And as Amory highlighted, it's proven that a lot of those misconceptions around the renewable grid are false. But we have to have a grid that adapts with our needs, adapts with the technology opportunities. I love the story about using EVs to really help act as the battery of the future instead of a lot of these centralized battery facilities. Down to the AI guys building these hyperscale facilities and just gobbling up huge amounts of water, energy, natural resources, instead of having these distributed blocks that are a lot more strategic. through to then the retail gas station example. And we come across this a lot, don't we? There's a lot of stores, restaurants, fuel stations that could be community resilience centers, but they're at risk of being the first to be down without power and having queues of people lined up, starting to panic in certain situations instead of being that local hub that can provide the fuel, the electricity, the food, the water, and really provide that opportunity of hope for people. And that's available to all businesses. And I loved his comment about, we shouldn't just be throwing renewables on a property and hoping that it can ride through an outage, because it can't. We need to be building that into all systems. And I think that's on us as well, actually, to be really driving our customers to be thinking that way. There are profitable opportunities to be had, but there's also resilient and business continuity opportunities with an incremental cost adder, but with long-term benefits.
Yeah, I think one of the biggest things that you just spurred as you were sharing that was just the need to look ahead and learn from the past, but not project the past into the future, but understand that it's a very different world as we move forward in the next 5, 10, 30 years. And a different approach is going to be necessary to thrive in that new world.
Yeah. And change is scary, isn't it, for many of us? And I think there's the opportunity here is let's continue to bring on awesome guests like Amory to educate our listeners and business leaders and people who can actually make the change. But let's also work together as a community to learn by doing and get after it and make these changes, but all then celebrate the successes and learn from those that maybe don't go to plan. And there's going to be some of those for sure. But yeah, so good. I really appreciate his insights. Great way for us to celebrate our 100th. Congrats.
Yep.
Let's press on.
Absolutely. Good stuff, Gareth.
Appreciate you.
See ya.
We receive a lot of questions from business leaders around the world wanting to learn more about the energy transition, what is possible, and where to start. So to help you stay informed and up to date on best practices, opportunities, risks, and success stories, we created an industry newsfeed at VECKTA.com/news with all our podcasts, blogs, and newsletter. Check it out and connect with Dan, myself, and the VECKTA team to learn more. Cheers and have a good one.